Hello, my name is Arthur, and in the last video we did the option for whole word, and it turns out that I made a mistake in that video, so we're going to do a correction to that mistake and fix a problem with the whole function, the search text function. So first off, we'll look at the first problem. So we got things that they appear to be working. So if we do a search with case sensitive, it reduces the number. And if we do a search for just a word, it reduces the number and seemingly to the place that we want it. But unfortunately, my search was not specific enough, so I didn't experiment enough with this to catch that I'd made a mistake. So right now we have the whole word G being searched for, and it's getting results that are not whole word. So there's a problem there to lead for that to happen. So we'll go back to GTK. In the last video I mentioned that I need to come up with a way to make the text view sensitive to having typing going in it so it can adapt to a search. So I figured that out, and we can see I can make it unhighlight or rehighlight according to text being entered into here. So let's just make that bigger so we can see that more clearly. And then if I was to do the same thing on the other side, the highlighting doesn't change. So obviously there's a problem in the whole word function that we'll have to fix. So the other problem is here. So what I've done is I've added in a counter, and the counter is only incremented when a tag is applied, and then I'm printing out the counts to the terminal. So this count is representing the first time that I open the search bar without anything in this field. So if I empty this field and I close the bar, when I open the bar, I'm getting 8,000 hits, and the first time I'm getting 18,000. And the count is only going up when tags are being applied, so that would imply that 36,000 tags were applied to I don't know where, because we can't see that, and we can't see 8,200 tags being applied either, but it does represent undefined behavior. So it's behavior that we're not expecting. We don't want behavior that we're not expecting, right? So let's close this up. The first thing we'll do is we'll have a look at how I got the text view sensitive to typing when the search bar is open. So that began with putting a global boolean for searching in place. So we'll just search for that so it's easier to find. So we put in the boolean, we declare it as false, and we toggle it on and off. Now search is the function that happens when we press this button and the search bar is first opened. So when the search bar is open, searching becomes true, and when it's closed, it becomes false. So the boolean basically represents whether the search bar is showing or not. Now, I was having troubles with the signals, and probably because I was trying to hook signals up to individual tabs, and that's just something that wouldn't work. Seemingly it works with these buttons on the tabs, but it doesn't work with the buffers or the text views. So instead of doing it that way, I tried doing it with the notebook. So let's just take that out. We can see this is where searching is applied. So the signal in the notebook is a key release event. So that's anytime we press a keyboard key, there's a press event. And when we let it go, there's a release event. So we're calling for a signal on the release event, and we're just sending it to a function called key release, which is right here. So what the function does, if it determines if the search bar is open or closed. So if it's closed, it doesn't do anything. And it checks if the length of the search buffer is greater than 0. So if there's nothing in the search field, it's not going to do anything, and it doesn't call the search text function. So that way it only calls the search text function when we're typing in the field. There's something, when we're typing in the text view, there's something in the search field, and the search field is open. And it's that way because the search field can be closed, but it can still have text in it. And as an example, searching is still inside of this. Now, on this software, it assumes we're going to do a new search, but I'm not going to make mine have this behavior. I'm going to make it have behavior that when we open the search bar, it's going to re-highlight the last search rather than do it this way, because I think that the other way makes more sense to me. So I'll make it make more sense to me. So that's what the signal looks like. That's how it's used to get the text view to respond and the search to respond to changes in the text view with changes to the highlighting. So way up in the search text function, that's where the search actually happens. And maybe I should have named these functions better to be like search bar and hide search bar, or maybe show search bar and hide search bar. But be that as it may, I named them as I named them, and it's not critically important exactly what their name is. So this is the fix to the 18,000 apparently same thing is to be found in an empty buffer results that are being encountered. So we'll do the same type of check in search text. We'll check if the buffer length is equal to 0. It'll just get kicked out of the function. So that it won't find a whole bunch of instances of nothing, or whatever it's finding in an empty buffer that's comparative to something inside of the text view buffer that's full of text. And the 18,000, that actually has to do with the document that I keep opening as our test document. So that piece of script that I keep opening, because if I was to change text in that script and then open the search bar, the number would change. So it's something to do, probably something to do with in white spaces or something like that. But I'm not really sure exactly what that is. So the problem with the whole word search is, if we were to look, this is the part of the function that's for the end of the line or the end of the word. And if we were to compare that to this one, we would see that something is missing here. I haven't identified the iter. So I don't actually know what would happen here, what happens here as a result of not identifying the iter. Now, I did change one thing here in my experiments. I went backward char, and I don't know if that matters. So let's change it back to what it was, position. Because that was backward cursor position and enter before. So we'll put it back to what it was in the last video just to see if it does make a difference. So I failed to identify the iter, and I like to, because I've put iter in place of start, I like to use its avatar as an avatar for start because it's in the same place. So yeah, we'll just see what this effect has. I don't think that it should change anything though. So yeah, that's a pretty simple oversight, and I'm not sure why it even runs with just GTK text editor starts line with no arguments and no brackets beside it. I'm not sure why that runs like that. You would think that it would be something unidentified, but I guess it isn't. But to me, it seems like it should change its nature to not have this here to a different type of identifier. But yeah, for some reason it compiles and runs, and I'm not the wiser until I see the aberrant behavior of the strange search results that we shouldn't be seeing. So we'll put iter in there, and we'll make sure that it works with the cursor position exactly the same as it does with the forward char, or the backward char I should say. So we'll make sure that's saved. We now have the check to stop an empty buffer from showing those large numbers. And just glance to make sure I did everything right. And we'll run that again. So let's open our test document up for the sake of consistency. We'll look at our numbers here. So we'll open the window. Now we're not getting 18,000 results for whatever's in an empty buffer that it's finding in our text document. If we type in a G, we get 469 hits for that. If we make it case sensitive, it's then 392. And if we make it whole word, it's now 0, like it should be. So let's change that to GTK. We get the 3 hits, and we want to see an underscore changes the highlighting. A number will change the highlighting. And let's increase the size of that view so we can see. So we have a number, we have an underscore at the end. So let's do something at the start, a letter, and let's do a symbol that it should accept. So it should accept a quotation, a plus, an equals, a minus, a slash, a slash. These are all acceptable characters that don't change the nature of the identifier, and the highlighting is remaining for those. So we'll check the active search. We'll turn off whole word to see that it is very active. And that seems to have everything working up until we've taken that last delete out. So that last delete, let's try to see if we can see a reason for that. Now I thought we covered delete event. So we're gonna go have a look at I have an idea why that might be. Okay, that's something different. Now, I'm guessing that the problem is the location of this function. So we're going to take this statement, that comparison out, and we're going to put it just after it deletes tags. Because by this point, if there's nothing in the buffer, there should be nothing in the search result, but it's not able to delete it because its size equals 0. So we'll move that here, and we'll see what type of behavior we'll get from that. So we'll just discard that. We'll recompile it. We'll open our test document back up. We don't get the whole bunch of tags getting put in. We get the 469, the 392. We get 0. GTK. So we get the 3. We'll turn off whole word, and we'll delete the text. So we're down to 2, 1. So now that works better. So those are the fixes to the search text function. And let's give this one a little bit of space so that we can see it in there. So in the next video, what we'll be looking to do is get a start on next, previous, and scrolling. So when we do a search, and if we were to do a search for the word GTK, it would scroll, and where it scrolls to, I'm not really sure, because the behavior for this software is seemingly a little bit random when it comes to that scrolling. So the behavior I'll try to get is that it scrolls to the first instance of a word. So when we search for a word, it will scroll to the first instance, and then we'll have the ability to next and previous. So the first thing will be to just get that initial scroll to happen. So that'll be in the next video, and that's it for this correction video. And until the next video, take care.